Hello, hope everyone is staying safe and as well during this COVID-19 crisis. But on a brighter note, I am demonstrating my automated door opening system that I've designed using an LPC 802 board, a breadboard, a 7-segment display, a user button, and a bunch of jumper wires. And I am going to be demonstrating how I achieve this functionality. So unfortunately, because of the global crisis, I was not able to procure all of the hardware sensors that I wanted to use for this project. But I've made use of the temperature sensor, which can be a little finicky at times. But as long as we provide it enough heat, it is able to detect it, and it is able to represent or translate it to the output. Now, what my project or my circuit here basically does is whenever a user presses the button, or if a temperature greater than 32 degrees Celsius is achieved, it triggers an output which is in the form of either the GPIO 7, the LED related to the GPIO 7, or the LEDs related to GPIO 9 getting triggered. Those are off right now, but we can just turn them on in a second. It also shows an O on the top here. Right now it says C representing closed, and it says an O for open. So I'm just going to run my code right now. And in the meantime, the LM75 sensor, which comes with a board, I have gotten the input and triggered interrupts when a certain temperature is recorded. We read the temperature, and in order to collect the data, we use the I2C serial input protocol. And for the user button, whenever a user clicks the button, again, a pin interrupt to be specific, is triggered, and both these interrupts set their relative flags to true. And in our multi-rate timer, which I have implemented in order to use pulse width modulation with a duty factor of 70%, trigger an interrupt, and whenever the multi-rate timer on its repetitive interrupts, because it's a MRT repeat, encounters that the flags were set to true, it turns the necessary LEDs or the segments light up on the 7-segment display. So I'm just going to run my code, and we have to give it a couple of seconds for the sensor and the GPIOs and all of the hardware components to just sync and get configured. So once we've given it a couple of seconds, I'm just going to hit the user button. Now, it might still be in the wait time, so usually takes a couple of tries. Lights it up, says an O, and it's a 70% duty factor, so it should stay on for 70% of the time. And if it does not encounter another button click, it is going to stay closed. But if we click again, again, it at times is a little finicky. It also depends on whether you've pressed the button properly or not. Lights it up. Now moving on to the temperature sensing part. The temperature sensing part has been, again, like I said, a bit finicky for me. So I'm just gonna go right up, and I'm going to supply it with enough heat because it needs to go over 32 degrees. Please be safe and please be careful around flame, because this is not the safest way of demonstrating this functionality, but here it is. So the door stays open as long as it keeps detecting the heat, and then it closes. So as you saw, when the temperature went up, the LED associated, which was associated with GPIO 9, lit up, and our 7 segments set. When the temperature went down, the LED associated with GPIO 9 lit up, and our 7 segments set. open. So that was all, and again, good luck you guys. Everyone, please stay safe. Thank you.